Hello everyone, today we're going to do chapter 4, The Location, class grade 7, prepared by Suraya Abdulkader and registered by Ahmed Hamad. Abscissa of a point. X prime OX is an axis of origin O called the x-axis. This is the X prime OX or the x-axis, which is the abscissa axis. It's horizontal. It has a midpoint called O and it goes towards the right. The positive goes towards the right and the larger number goes towards the right. As much as you go towards the right, as much as the number becomes bigger. So x prime OX. It starts by x prime from the left, midpoint O, and at the right x. And it's called x prime OX, or the x-axis, or the abscissa axis as well. The positive numbers are the abscissas of the points located on OX. All the positive numbers that has a positive abscissa are located where? Are located to the right of the midpoint. That means between O and X. We have 1, 2, 3, 4, 5. All these points are located to the right of the midpoint O. Positive numbers. We have the negative numbers or the negative abscissas are located between X prime and O. So as much as we go towards the left, the numbers become bigger in negative. So -1, -2, -3, like that, -4, -5. These are the negative numbers. Examples. The point A of abscissa 1, that means the distance between O and A is equal to 1, or x of A is equal to 1. We have the point B here. If the point B of abscissa -2, that means the distance between O and B is equal to 2, or OB bar is equal to -2, or x of B is equal to -2. The abscissa of B is equal to -2. The distance from A to B is equal to 3. It's written AB is equal to 3 or BA is equal to 3. Locate a point in a plan. Orthogonal system. We have, this is the orthogonal system. It's divided into horizontal and vertical lines. A reference or orthogonal system is formed by two axes, x prime OX and y prime OY, perpendicular in O. So this is the abscissa axis or x prime OX. It has positive numbers to the right of the O and negative numbers to the left of the O. And we have the ordinate or y prime OY axis. It's vertical and intersect with the abscissa axis at point O, which is the midpoint. They intersect perpendicularly, of course. It has the positive numbers to the top or upper to the O, and we have negative numbers to below the O or below the abscissa axis. The axis x prime OX is the abscissa axis and the axis y prime OY is the ordinate axis. The point of intersection O of the two axes is said to be the origin. So here, this is the ordinate axis in green, and this is the abscissa axis in purple, and this is the origin, which is the midpoint of both axes. Coordinates of a point. We have point M here as shown in the figure. A point M of the plane is determined by its coordinates. How do we know that this point exists here? We know this information by giving its coordinates. But how do we get the coordinates of a point? Its abscissa A on the axis x prime OX. So A exists on x prime OX, the abscissa axis. It's 5 here in our example. And then we give the second information in the coordinates, which is the ordinate B on the y prime OY axis. So we go to the left and we intersect with 3 on y prime OY. So the coordinates is formed from two informations, the abscissa and the ordinate, two numbers, A and B. Then we write M between parentheses, the abscissa, then the ordinate. Example, in the adjacent orthogonal system, 2 points A and B are placed. We have big A and big B. A is 3, 2. So the abscissa of A is a 3 and the ordinate of A is number 2. The intersection point between them gives us the point A. We have point B has abscissa -2 and ordinate 4, as you see in the figure. All the points having a 0 abscissa are located on the y prime OY, of course, and all the points having a 0 ordinate are located on x prime OX, and this is a rule that you must memorize. For example, M, as you see here, we have 0 as abscissa. It's located on the y prime OY. For example, the ordinate is 6. If we have M has an ordinate 0, so it's located on the abscissa axis, for example -7 as abscissa, or for example 8 or more than 8 has ordinate. The 4 quadrants in a system made up of two axes x prime OX and y prime OY, there are 4 regions of the plane. Quadrant number 1 or region 1, the abscissa and the ordinate of a point existing in the quadrant number 1 both are positive, and this is the quadrant 1 or region 1. Positive abscissa and positive ordinate. We have quadrant 2 or the second region. The abscissa of a point is negative, but the ordinate is positive. And this is the second quadrant, negative abscissa and positive ordinate. You have to memorize these information. You have to memorize this document or this. Quadrant number 3, the abscissa and the ordinate both are negative. This is the quadrant number 3. Negative abscissa and negative ordinate. We walk like that. 1, 2, 3, 4, like that. Anti-clockwise. And we have the quadrant number 4. The abscissa of a point is positive and the ordinate is negative, which is this one. How to place a point A -2, 5 in an orthogonal coordinate system knowing its coordinates. If we have a point, it has -2 as abscissa and 5 as ordinate. We locate the abscissa -2, we put -2 on the abscissa axis, and we have 5 as ordinate, so we go to the ordinate axis and we go to the number 5 in ordinate, +5, and we put a point. And then we join these 2 points by a hidden line. We have to draw the perpendicular to the axis x prime OX at a point of abscissa -2. And then we have to draw the perpendicular to the axis of y prime or y at a point of ordinate 5. And the intersection point, as I told you before, between these two lines, they intersect at this point that has an abscissa of -2 and an ordinate of 5, which is A, our point. The point A is the intersection point of these two perpendicular lines. It has -2 as abscissa and 5 as ordinate. Application 2. Construct an orthogonal system x prime o x, y prime o y having as unit 1 centimeter. Locate in this system the points A to 1, B minus 1 minus 1, C 0, 4, D minus 3.50, E 3 minus 4.3, and F minus 1.7, 2.1, E 3 minus 4.3, and F minus 1.7 and 2.1. Then find the coordinates of points H and K such that AH and BK are parallel to x prime OX and to y prime OY. And then indicate the quadrants of which the following points belong: L minus 3 minus 5, M 4.4 minus 2, and P 531 and minus 192. So first of all, we have to construct an orthogonal system x prime o x, y prime o y. We have to enumerate it, put the positive numbers to the right of the abscissa or to the top of the ordinate system, and the negative numbers to the left and to the bottom of the system. First of all, we have to draw or put A 2, 1. So 2 as abscissa and 1 as ordinate. We have B, which is -1 minus 1, here B. C 0, 4, so it's on the ordinate axis. D, we have minus 3.5 and 0. We have E 3 minus 4.3. F minus 1.7, 2.1. We have E 3 minus 4.3. And F minus 1.7, 2.1. So we located all the points. We have to find the coordinates of the point H and K such that AH and BK are parallel to x prime OX and y prime OY. So we drew the line AH, which is parallel to x prime OX now. H exists on this line. It could be anywhere on this line. So AH is parallel to x prime OX, so A and H have the same ordinate, have the same height, have the same Y, because they are parallel to x prime OX. They exist on the same level, on the same height. And H have M as abscissa and 1 as ordinate, of course, the same ordinate as I told you before, the same of A. A has ordinate 1, so H must have ordinate 1. With M is a decimal number, of course. And then we draw another line parallel to y prime or y as they told us and passes it through the point B. Then K exists on this red line, which is parallel to y prime or y. The same strategy, we say BK is parallel to y prime or y, so B and K have the same abscissa. Then K is equal to -1, which is the abscissa of B, and B, an ordinate. We didn't know it yet. With B is a decimal number. For L -3 -5, we can draw it, or we can locate this point on the system and then decide which quadrant it's located. And we can follow another rule, which is if we memorized the conditions of each quadrant, we can immediately decide which quadrant this point is located. We have L minus 3 minus 5. It has negative abscissa and negative also ordinate. Which quadrant that has negative abscissa and negative ordinate? It's quadrant number 3. So we can say immediately, without locating the point in the orthogonal system, we can say immediately that L belongs to the quadrant 3. We have M 4.4 and minus 2. Without locating this point on the orthogonal system, we can say immediately that it has a positive abscissa and a negative ordinate, which is the conditions of quadrant number 4. So M belongs to quadrant number 4. Going to P 531 and minus 192. If we have big numbers like that, of course we don't locate it, we don't try to locate this point in the orthogonal system. We can use the other rule that says it has positive abscissa and a negative ordinate, and these are the conditions of the quadrant number 4. So immediately we can say, without locating the point into the orthogonal system, that P belongs to the quadrant number 4. Thank you so much for your listening. I hope everything was clear, and goodbye.